Today we're going to talk about the holographic universe and simulated universe hypotheses. You may sometimes hear these referred to as theories, but there's an important distinction to be made. In science, a hypothesis is something that is testable and falsifiable. We form a hypothesis and then we test the claim. Then if our data doesn't fit, then it's falsified and we reject the hypothesis and we form a new one for testing. And if the data does fit, then we still have to test further before we have anything conclusive. A theory, however, is something that has been well tested and best explains a set of proven facts. An example of this is germ theory. Everyone I know is okay with the idea that germs make us sick rather than something like witches or Harry Potter casting spells, or the old miasma theory which proposed that bad air made people sick, generally thought to be due to rotten organic matter. An early pioneer of germ theory was Jon Snow. Although he wasn't the first to propose the idea. I don't really have anything else to say about it either. I just like Game of Thrones and I wanted to mention it. Anyways, from this we can see that the ideas of a holographic or simulated universe are not theories, they are hypotheses. I'm not a scientist, and I know this is a very difficult topic to grasp, but my attempt is not to explain it to people in a scientific way, but to show how we can be skeptical even if the research is extremely complex. For example, we don't need to disprove a claim to disbelieve it if the methodology is unscientific. However, to the extent that it is scientific, then we have to address the actual evidence, which means tentatively accepting the conclusions, that is, accepting the best evidence we have until better evidence comes along. We should also take care to note that the holographic principle, which is in large part the basis for the holographic universe hypothesis, is a principle of string theory. But this alone does not prove the hypothesis. The holographic principle is very complex, and not something that is just common sense, and experimental tests have not been conclusive. And aside from this, there's a debate as to whether string theory is even an actual theory since it fails to meet the requirement of falsifiability. This is a very complex issue and a debate for another time, but it does give us reason to be skeptical of the claims because we know they have not been proven true, nor has there been sufficient tests to prove it false. Let's look at an article from earlier this year. Phys.org had a fascinating article about the latest research done on the topic. Unfortunately, the actual research is locked behind a paywall and costs $25 unless you have access to the journal. But what's worth pointing out is that phys.org never calls it a theory. Scientists understand this, but since the idea has become more mainstream, the wording has been thrown around more loosely. It's also worth pointing out that the idea is not really the same thing as the idea that we are living in the Matrix. That idea is the simulated universe hypothesis. And while both ideas lead to the conclusion that our perception of reality is just an illusion, they are very different ideas. Proving one wouldn't prove the other, and as the evidence grows for the holographic universe hypothesis, it seems that more and more people are conflating the two ideas and thinking that this somehow proves that we're living in a computer simulation. However, this is not the case. And this isn't to say that the simulated universe hypothesis is less scientific than the holographic universe hypothesis. There are proposed tests that can give us some insight, but the ideas being spread often confuse the holographic universe for the simulated universe, and therefore the same flawed reasons are given for both ideas. And the reasons often given for believing in these two ideas are unscientific. In fact, the reasons tend to be based on only logic and probability, which is fine if you know the actual probabilities. But when you don't know the probabilities, then you don't have a good argument. Elon Musk has said that in the future we'll have billions of simulated realities all sufficiently advanced to be indistinguishable from reality. But what if we're living in a multiverse with an infinite number of universes? Then the probability we are living in a real universe is 1 in infinity. Even if each universe has billions of simulations, the odds are still 1 in infinity, and it seems far more likely to expect that in an infinite multiverse there would be an infinite number of universes where life forms are advanced enough to make computers, and an infinite number of universes where life never forms long enough to make advanced technology. So it seems the probability of living in a real universe would be 1 in infinity, and the probability of living in a simulation could be 1 in infinity. I'm not the first person to point out that this seems a lot like a theological argument. The argument goes that the universe is very unlikely to exist, but a universe would be exactly what you would expect if God exists. The counter-argument being basically the same. We don't actually know the probability. Do I know the probability of the universe existing? No. But I also have no reason to think that the existence of a God or God would be any more or less likely than the existence of a universe without a deity. In this way, the belief that we live in a simulation remains no more convincing than any other failed creationist argument. Also, why would the quality of the simulation matter? If we were living in a computer simulation, then we wouldn't know what reality looks like. So no matter how primitive the simulation would be, it would be indistinguishable from reality for anyone inside the simulation because that's all they know. And they wouldn't be able to test what reality is actually like, they would just be able to test what reality seems to be within the simulation. This also gives us reason to question the idea that if the universe has characteristics of a computer program, then it's evidence we're living in a simulation. Wouldn't some characteristics of a computer program be due to the limitations of the universe the program exists in? It has been argued that the fact that the universe has tiny building blocks is similar to the way computer simulations have pixels. But the fact that the universe has particles that are, as far as we know, the smallest units of matter means that anything we build will have a limit on how small it can be. So while a computer program may make the illusion of a perfectly straight line, when we zoom in far enough, eventually we'll see a zigzag of the pixels. But this isn't necessarily because we live in a computer simulation, but that computer simulations have limitations set by the computers they run on, and those computers have to follow the laws of physics. So the simulation itself may have its own physics within the simulated world, but this doesn't change the fact that the computer it's running on exists in our world and isn't affected by the simulated world's physical laws. So now let's look at how the same topic is being treated by the mainstream media. An article in the New Yorker last week wants to know if the Oscars just proved we're living in a simulated universe. The whole thing is a little ridiculous. It gives the same reason I mentioned before about only one real universe and many simulations, and on top of that it goes into length about how many weird things have happened lately, starting with the unexpected victory of Trump, then moving to the historic Super Bowl last month, then ending with the mix-up that happened during the Oscars. It tries to make the case that we're living in the Matrix and that something went wrong with the controls. And as for fun speculation goes, this can be an entertaining idea to think about, but that's all it is, speculation. Speculating what if. However, if we want to do more than speculate, then we have to use science. I also have to give the article some credit because it manages to use the words hypothesis and not theory. However, the argument given is weak and based on ignorance and not actual evidence, and this is the problem that the hypotheses face. They have leaked into the mainstream, and so people are commenting on them who they themselves don't fully understand it, or may believe that there's more evidence than the data actually supports. Or when they do understand it, they explain it in simple terms, which gives the impression that it's a simple topic that can be easily tested, when in actuality, we may never have a conclusive test. In the end, you're free to believe whatever you want. If you think there's sufficient evidence to warrant belief in these hypotheses, then you're entitled to that opinion. And if you don't think there is sufficient evidence, but you just want to believe it anyway, then you're free to do that as well. But in actuality, there's a lot more research to be done before we know anything conclusive, if we ever do. In the end, we may never know the origins of our universe, and I'm okay with that. I think it's better to admit when we don't know something and keep exploring. Keep searching for the answers and following the evidence wherever it takes us. So what do you think? Do you agree or do you disagree? Let me know in the comments below, and if you like my work, please subscribe to my channel, and thanks for watching.